Okay, new lesson, lesson 5. Okay, this is I guess the last one you'll do for systems of equations. Actually, I like this one. This is fun. It's called elimination. Okay, we're going to solve by elimination. And this is, what do we call these? 1 second. Oh, I'm writing up here. Notes 5. Okay. You have already developed some useful strategies for solving simple linear equations like this. You know that you can add or subtract the same quantity on both sides and preserve the equality. So the equation will stay the same when we move things around. The same is true for multiplication or division. These ideas called the properties of equality can help you develop another method for solving linear equations. This method involves combining separate linear equations through the 4 basic operations into one equation with only one variable. Other names for this method are combination addition or elimination. I call it elimination. And I'll show you why. We want to eliminate one of the variables. And the way to eliminate one of the variables, ideally, is if one is positive and one is negative, they cancel each other out. So when I look at number 1, the setup is perfect. Okay? X plus y equals 3, x minus y equals -9. Watch what I'm going to do. I'm going to draw a line here and go, okay, I'm not using substitution. I'm not graphing these two. I'm going to eliminate. And what variable is screaming elimination? If I add down, work your brain down, the y's will eliminate each other. They are opposite to each other. So they eliminate each other. It works. I add down, I get x and x is 2x. Equals a -9 and a +3 makes -6. Okay? Solve for x. Divide by 2. Divide by 2. X equals -3. Guys, when you get to this step in the elimination, you still have to substitute. Because I got x is -3, now I'm going to go back up there. Pick whichever equation. So I'm going to go take the top one. X plus y equals 3. If x is -3 plus y equals 3. I'm solving for y now. If x was -3, I substitute in. So I got to go +3 here, +3 over here, so I get y equals 6. There's my answer. So my solution is -3, 6. Done. Now, some setups, right away you'll notice you can eliminate. Some you're going to notice you have to substitute. It depends on what you see and to proceed. You can do it both ways. It doesn't matter. So let's look at this one. Screaming elimination right here. The 2x and the -2x cancel each other out. Okay? Let's zoom in a little bit. Do we see that? The 2x and the -2x cancel each other out. I draw a line underneath. They cancel out. They're done. These two make -4y and 6y make 2y equals what? 6. Divide by 2, divide by 2, y equals 3. Okay, so in this case I got y is 3. Pick one of them. Go to the top one. 2x minus 4y equals 10. So now I'm going to put in y is 3. I get 2x minus 4 times 3 equals 10. 2x minus 12 equals 10. Add 12. Add 12. I get 2x equals what? 22. Divide by 2. Divide by 2. X is 11. The second step is longer than the first. Whoops, right out of the page. So my solution here is 11.3. We good? Okay, let's try this one. Do you see something that can eliminate? The x terms eliminate each other. We're going to find ones that are harder, and I'm going to teach you that, but these are nice and obvious. The x terms eliminate. They're opposite of each other. One was positive, one negative, opposite of each other. So they eliminate. I add up the y's. This makes 2y equals 4. So nice. Divide by 2, divide by 2. Y equals 2. Go back to one of the equations. 2x plus y equals 3. So I kind of took the top one. And I'm going to put y is 2. Put it in there. 2x plus 2 equals 3. Subtract 2, subtract 2. I get 1 over here. So 2x equals 1. Sorry. Divide by 2, divide by 2. So x is a half. So the solution here is 1/2 is x, comma, and y is 2. I'm not crazy about fractions, but I guess, fractions exist. Okay? Let's look at this one. Does something scream elimination? Yes, the y's eliminate. So I get 2x equals 36. Divide by 2, divide by 2. 36 divided by 2 is 18. So if x is 18, put it in the first one. The first one is x plus y equals 30. Right? If x is 18 plus y equals 30, so we're going to subtract 18, right? So y equals 12. So the solution here is 18, comma 12. Okay? I don't know if I went too fast, but that's elimination. It depends on how the equation's set up, if things will eliminate easily. All right, now. Okay. Now this one is not perfect. And the reason it's not perfect is we don't have same numbers with different signs. If this guy was positive and that was negative, beautiful, eliminate. But they're not. But guess what? You can make it so that they will eliminate. And how do I make it? I multiply one of them, one full equation, by a number that will make one of the variables eliminate each other. So I'm not going to work, not touching these, but I definitely can work the y's. If I can create a positive 7y here in this top equation, it'll get rid of that 7y, the negative 7y. It'll eliminate. How do I do that? I multiply the whole top equation up here by a -1. Watch. I'm going to write, put parentheses around the whole equation. Okay? Zoom in a little bit. Oops. Zoom in a little bit so you can follow me. I put whole parentheses around the top equation, and I'm going to put a -1 in front. And then I'm going to rewrite it over here. So the whole equation, the whole number sentence equation, will change signs because I multiply by -1, the whole top. So now the new equation is -6x, positive 7y, all equals negative times negative makes positive 4. See how their signs all changed? I'm going to rewrite the exact bottom underneath. -4x, -7y equals 26. The bottom one did not change. So this is where I am changing. I'm going to change one equation. And how do I do that without changing the value? I multiply the whole equation by a number, the same number. Okay? Now this eliminates. They're gone. The y's are gone. This makes -10x equals 30. I add it down, divide by -10, divide by -10, so I get x equals -3. Easy. If I have x is negative 3, pick one equation up there. Go back to the original. I'm going to take the very original. 6x minus 7y equals negative 4. So now, again, you're still substituting. X is negative 3. 6 times negative 3 minus 7y equals negative 4. Negative 18 minus 7y equals negative 4. Add 18, right? Add 18 over here. So I'm going to continue this over here. So I get negative 7y equals a 18. What's this? An 18 and negative 4 makes 14. Divide by negative 7, divide by negative 7. So y equals negative 2. So the solution, where would I have felt this? There we go. So the solution here is negative 3 comma negative 2. This point will work in either one of those equations and make it true. It's one way of checking it. Got it? Cool. Number 4. Okay. I'm staring at that going, these aren't going to cancel each other. Not going to work. But these could if I can make this guy negative or that guy negative. Doesn't matter. So I'm going to multiply the whole top by negative 1. So this changes this to be negative x plus 3y all equals 9. Right? Copy exactly. Do not take shortcuts here. You follow me? I copied exactly the bottom equation over. The top one I multiplied by a negative 6. Excuse me, what I'm saying, negative 1. Negative 1. X's cancel. The y's actually make, oh, this is nice, makes 1y equals 3. So y is 3. Got it? I'm going to try the first equation, x plus 3y equals 9. If y is 3, x plus 3 times 3 equals 9. X plus 9 equals 9. What's x got to be? X must be 0. Solution is 0, 3. And if you put that in up here, it works. Okay? Let's try this one. I want to get rid of the x's because it's 5 and 5. One of these has got to get changed. So I'm going to multiply the top by negative 1. So this makes this whole top becomes negative 5x minus 7y equals negative 77. Bottom is 5x plus 3y equals 53. You with me? We good? Eliminates. These two make what? Negative 4y equals, I'm sorry, I'm getting lazy here. 77, take away 53. Oh, that should be easy. It's what? 24, isn't it? Yeah. Negative 5, right? 4. That's 7, 20, negative 24. Divide by negative 4. Divide by negative 4. So y is 6. So if y is 6, put it in either one. Whichever one. Do the bottom? Let's do the bottom. 5x plus, I'm off the page. 5x plus 3y equals 53. So if y is 6, I'm going to put it there. 5x plus 3 times 6 equals 53. 5x plus 18 equals 53. Got to minus that 18, so I get 5x equals, what's 53 minus 18? I'm cheating, I'm using a calculator right now. It's 35. divide by 5, divide by 5, so x equals 7. So my solution here is x is 7, remember x is first, and the y is second. Nice, easy. Okay. How do I do this last one? Okay, the y's would be nice if they would cancel out. Right? But they're both negative 3y, so I have to multiply one of them, so I just stick with the top by negative 1. Negative 9x plus 3y equals negative 24. Multiplied by negative 1. The bottom is 7x minus 3y equals 20. Didn't change the bottom at all. Did not touch it. Bye-bye. These two make negative 2x equals lovely, lovely negative 4. Divide by negative 2, divide by negative 2, x equals 2. Okay? Now find y. I'll do the second one. 7x minus 3y equals 20. See, I'm just copying it from there. And I'm going to say if x is 2. 7 times 2 minus 3y equals 20. 14 minus 3y equals 20. Subtract 14. Subtract 14. Negative 3y equals 6. Oh my goodness, I'm sorry. This is what happens when I zoom in. Oops. Okay, so I copied that equation, substituted x is 2, working it out, right? Move the 14, get 6. Last step, divide by 3, or negative 3, divide by negative 3, right? So y equals negative 2. So the solution here is 2 comma negative 2. We good? Okay, so next page is a little interesting here. Now let's investigate some other systems that involve other uses of the elimination method. All right. The page before I was multiplying, first off, they either eliminated perfectly, easily, opposite signs, they just eliminated, or we forced it by multiplying by negative 1. Now I'm going to take a look at this and go, multiplying by negative 1 is not going to work here. Multiplying by a negative 2 for this bottom equation will eliminate the top. Do you just follow what I'm showing you here? Okay. Hang on, I'm bouncing around here a minute. Okay, let's take a look again. If I had a negative 2 right here in front of the x, the x's would eliminate. Can I make it become a negative 2? Yes, by multiplying the bottom equation, the whole equation, by negative 2. When you eliminate, you have to multiply the whole equation by a factor. So I'm going to go like this. Multiply by negative 2. And it changes the bottom. So I get negative 2x, negative 2y, well, times 0 is still 0. The top equation stays exactly the same. 2x plus 5y equals negative 1. Okay? Now eliminate. What does this make? 5 and take away 4 is 1. 1y equals negative 1. So y is just negative 1. Go back up here. I'm going to go to the easiest one. The easiest one is the second one. X plus 2y equals 0. X plus 2 times negative 1 all equals 0. X minus 2 equals 0. Now I got to move the 2, right? So so x equals 2. So the solution here is 2 comma negative 1. Okay, so let me reiterate that. I studied the two equations. If I had a negative 2 in front of the x, I can eliminate the x terms. How do I get that negative 2 there? I multiply the bottom equation by negative 2. Line them up, eliminate, solve for y, then substitute in to get the x. Let's have a look-see at the next one. The y's could eliminate if one was negative and one's positive. So I'm going to change it. I'm going to change the top. Multiply by negative 1. So I get negative 6x, negative 3y, all equals 0. Negative 3x plus 3y, all equals 9. Y's are gone. This makes negative 9x equals 9. So what's x? Divide by negative 9, divide by negative 9. X equals negative 1. This is kind of an easy one. If x is negative 1, I'm going to go to the first equation. 6x plus 3y equals 0. Put a negative 1 in there. 6 times negative 1 plus 3y equals 0. Negative 6 plus 3y equals 0. Add 6. Add 6. 3y equals 6. So what's y got to be? Divide by 3. Divide by 3. Y equals 2. So here the solution is negative 1, 2. Okay? Let's try this one. Oh boy. All right, so, gee, wonder how I can get things to cancel here. Can I get things to cancel? Couple ways. Actually, 2 ways. If I want to cancel the x's, I'd have to multiply the bottom by negative 2. If I want to cancel the y's, I multiply the bottom by 9. Because if I got a positive 9 there, they'll cancel. I'm going to go with the 2, with the x. I'm going to multiply the bottom by negative 2. So the top stays 8x minus 9y equals 19. The bottom becomes negative 8x, negative 2y equals positive 14. Okay? So now the x's are gone. This makes negative 11y equals, what does this equal? 33. Divide by negative 11, divide by negative 11, y equals negative 3. Okay, so if y is negative 3, I'm going to go to the second one, looks easier. 4x plus y equals negative 7. So I'm subbing in here. Y is negative 3, so 4x minus 3 equals negative 7. Add 3. Add 3. So I get 4x equals negative 4. Divide by 4, divide by 4. X equals negative 1. So the solution here is negative 1 comma negative 3. Okay? Okay, so the next one. Next one, draw a line across here, so separate them a little bit. Okay. If I had a 2 up here, they would eliminate. So guess what? Multiply the top equation by 2. Multiply the whole top by 2. And that's going to change it to 8x minus 2y all equals 12. Keep the bottom, 3x plus 2y all equals 21. Shoot. We good? See how I did that? Get rid of the y's. They eliminated. So this makes 11x equals 33. So what's x? X equals 3. Right? X is 3. Go to the second one, looks easier. 3x plus 2y equals 21. So I just copy it down. Now I'm going to sub in. 3 times 3 plus 2y equals 21. 9 plus 2y equals 21. Minus 9, 2y equals, what is it, 20? Is what, 12? Yeah. Right? Divide by 2, and y equals 6. Okay? So have we got this concept? So the solution here is, oops, 3x is 3 comma 6. Your solutions are the real answers here, guys. I should have been boxing off solutions. Okay? Again, the solution up here, and the solution here. The real answer is the solution, where the coordinate is, the xy coordinate. A little bit of work, that is for sure. But not hard. These numbers are not hard. Fairly easy. All right? So, the next thing is your homework for the systems. Okay, solve by elimination. So this page is all elimination practice, where things will cancel out or you make them cancel out by multiplying. Okay, elimination. Oh, graphing. Back to good old graphing practice. Okay, so 2 pages. That's all. 2 pages. Again, you can do it. Okay. Take a day or so to do it. Let's not rush through this. Excellent.